Hey guys, this is Mrs. Grella. I know there's some Khan Academy videos I posted, but I just want to kind of go through with you again on how to find missing angle values when there are parallel lines cut by a transversal. So again, the parallel lines are horizontal here, and then the transversal is kind of diagonal, slanted. And it tells us that the measure of angle 2 is 60 degrees. So this one is 60 degrees, and I want to find the measure of all the other angles in the diagram. So you can kind of do this knowing your properties of vertical angles from the last week, and also a linear pair supplementary angles that form a straight line. So for example, angle 2 is vertical with angle 3 because they're opposite each other on the intersecting lines over here. So angle 3 would also have to be 60 degrees. All right, now if I'm looking at, let's say this here as a straight line, if I know that this angle here is 60 degrees, I can kind of figure out what angle 1 is, because angle 1 and angle 3 make a straight line, this pink line here. So remember, there's 180 degrees in a straight line. If I take away 60 degrees here, I'll be left with what's left for angle 1. So if I take that away, I get 120. So angle 1 must be 120 degrees. And that makes sense because if you look at now this straight line where angles 1 and 2 lie, angles 1 and 2 form a straight line. 120 and 60 would give me the full 180 that is meant to be that straight line. So angle 1 is now 120. And angle 4 must also be 120 because those are across from each other also. They're vertical angles. Also 120 makes a straight line with the 60 here as well as the 60 up here. There's so many ways you could look at it. But really that would be the measures of those angles 1, 3, and 4 as well as angle 2, which was given to you. If you notice, all of these add up to 360 because it's a circle, which makes sense. You have 180 and then 180, giving you a full 360. Now, angle 1 is corresponding with angle 5. So they're equal. They're like this, basically in the same position. So I know that angle 5 must be 120. Angle 2 is in the same position as angle 6. So you can kind of do this for all of them and realize that they're just going to repeat values. Angle 4 is in the same position as angle 8. So it would be 120. And then angle 3 is in the same position as angle 7. So they would match up too. You can see also that, for example, angle 4 and angle 5, those are alternate interior angles, right? They're both 120. They're equal. Angle 3 and 6 are alternate interior. They're both 60 degrees. They're equal to each other. Angles 1 and 8 and angles 2 and 7 are alternate exterior angles. Angles 1 and 8 are equal, and angles 2 and 7 are equal. Alternate exterior angles are equal. So that's another reason why that works. So basically, you'll have angles that are either equal to the given angle, like 2 and 6 are equal because they're corresponding, 2 and 7 because they're alternate exterior, 2 and 3 because they're vertical, or equal to the supplement, 120, the supplementary angle. Again, I know that this forms a straight line, a linear pair. So angle 2 and angle 1 must be supplementary. So angle 1 is 120. And then based on that, I can kind of figure out, all right, angle 1 matches with angle 5. Angle 1 is alternate exterior with angle 8. So they're the same. And then 1 and 4 are vertical. So they're equal as well. So that's what you would get. So basically, you can see that if you have an acute angle over here, all the other acute angles in the diagram will be the same. And then if you have an obtuse angle over here, it's going to be supplementary with the acute angle. All the obtuse angles are the same. O is for obtuse, not 0. So it's going to be the same thing. So if you have O is equal to O. If you have two obtuse angles in the diagram, they're going to be equal. If you have two acute angles in the diagram, they're going to be equal. If you have one O with one A, they're obviously not going to be the same, but they'll add up to 180. They're supplementary.